Alrighty again. So, welcome to the channel. Today, tonight, this morning, wherever you are, we're looking at modeling transition matrices and state matrices with the addition of a part, basically. So, you can see some common parts to this heading up here where we've got Sn plus 1. So, any state matrix plus 1 application of the transition. So we take, say, S0 to start with. Then we're going to add this little bit here is the new bit, the B. So that's going to mean that we have a state matrix, but then we add something to it. And the example that we come up with or that's used will show you what that looks like. Okay, so a rental starts with 90 cars, rental company, 50 located at Bendigo, and 40 located at Colac. Okay, the cars are usually rented and returned in the same town. However, a small percentage of cars rented in Bendigo are returned in Colac and vice versa. The transition diagram, this one here. Sorry, diagrams here. Down there's the matrix. Gives these percentages. So you can see 80% return to Bendigo, 90% return to Colac. So the 10% left over from Colac go to Bendigo. It's getting a bit thick, that pen, isn't it? And the 20% left over go to Colac. Okay. To increase the number of cars, 2 extra cars are added to the rental fleet at each location each week. The recurrence relation that can be used to model this situation is shown here. So where SO, so the initial state of or the initial number of cars at each location is 50 and 40. And then we have Sn plus 1 equals T times Sn. So that's our standard part that we should be familiar with by now, plus B. Okay. And we want to determine the number of cars at Bendigo and Colac after 1 and 2 weeks. Okay. So the increase of cars to the fleet is going 2 extra at each location, and that is 2 extra at C and B. Okay, so now calculate, determine the number of cars at Bendigo and Colac after 1 week. So 1 week, let's have a look at that. 1 week is going to give us something that looks exactly like this. So it's going to be SO equals 50 on the top there, 40 on the bottom, and Sn plus 1 equals our transition matrix, 0.8, 0.2, 0.1, and 0.9 there. Okay. And that's multiplied by Sn. Sn for this first one is going to be S0. So 50 and 40 plus B, which will add 2 cars to both sites after everything is said and done. Okay, so we've got, just to label it clearly, we've got T times SO and our B matrix. Okay, we punch that into our CAS and we end up with the number of cars in each place at the end of that time frame. Okay, so up here I've already set up the matrices needed for this. So you can see I've got the transition matrix named T, and that's multiplied by S. And then on top of that we add B. So after that we get S1 is 46 and 48 cars respectively. Now we're told that there wasn't a lot of information here around the matrices, but we're told that there were 50 in Bendigo and 40 in Colac. So that means that our 50, so that Bendigo is our top value, Colac's our bottom value there. So again, Bendigo's our top, Colac's our bottom. Remember, if you're answering the question correctly, you will state that Bendigo has 46 cars and Colac has, Colac, can't spell Colac, 48 cars. Okay. Anything else there we need to think about? All we can see, interestingly enough, is that Bendigo started with the most cars and now it's dropped below. And hopefully we can see the reason for that is that each week Bendigo's losing 20% of its cars, whereas Colac is only losing 10%. Okay, so that's going to flip the numbers there. Once we've got S1, scroll down just a touch. Once we've got S1, we can work out S2, and we can do that. We'll go, so S1 plus 1 transition is equal to, I'm not going to write out this now, but we put the transition matrix in there, times that this time by S1, okay, because we want to get to S2. To get to S2, we must times S1 by the transition. So that's S1, and we're going to add B. 2, 2, there. So each week we get that. So in your CAS, now we've got an answer here, which is S1. We don't need to do anything with that. What we can do, hopefully you picked up on this already, is that, and we're going to pop our answer and then plus B. Alrighty. And we get a result of 43.6 cars and 54.4. Now, if we, obviously you can't have 4/10 of a car or 6/10 of a car, so we'd round that and say that there are 44 cars at Bendigo and 54 cars at Colac. Now we might want to just do our checks here. So we've added, in total we added 4 cars here, 4 cars there, so that's 8 more all up on the total that was 90, so hopefully this adds to 98. 50 and 40 is 90, 4 and 4 is 8, so we get 98 cars all up. One other point to note here when you're doing this, if you get one of these questions and with the T times SN plus B, so you're adding the common difference, I guess you could call it if you're familiar with the recursion work we used to do, is that you can't perform this as a rule. So this has to be recurrence. Okay, it's recurrence all the way. Okay, we can't have T to the power of N times SO plus B. Okay. What happens is that you get these additions, the powers of the matrix, but you're not actually applying the B every time you apply the power. So that is not an option when we have a B involved. Hopefully that helps out everyone a little bit. Have a fantastic night, morning, day, Christmas, if that's what you're doing. And we will see you next time. Give it a like, etc. guys. Bye.